What is Simpson's rule? A method for approximating a definite integral using parabolic approximation of f. How to apply the rule? Firstly, you see there's a A and okay. How to apply the rules? As you can see in this diagram, there's y-axis and x-axis. So that's the graph. This graph is y equals to f bracket x bracket. Okay. When you see this graph, first you divide it. You find your A and find your B, and divided it into equal parts, which means use this formula. But you must remember that your n is an even number. Okay, now let me show you example 4. Example 4, the RMS value of voltage is VRS equals to square root 1 over B minus A. Integral B A V square D dt. For the integral B A V square dt, we can apply the Simpson's rule. And for our H is equals to 0.01 is given in the example 4. And for V, the value of V is already given in example 4. So y equals to V squared. And all this value we square all the V value and get and we do until A equals to 0.1, which is equals to B. And we label the first column y0 until the last column y10. Okay, we use this formula, and we use the Simpson's rule. And all this value we can find in the table. And we sub all the value into this formula. And we get 80.4633. And VRMS is equals to square root 1 over B minus A, integral B A V square dt. And we sub all the values in, like B equals to A plus 0.1 in. And we cancel the A, and we sub in the values, and we square root the values, and equals, the final answer is 28.37 millivolt. Now let's compare between Simpson's rule and Temperature rule. This is Simpson's rule and this is Temperature rule. So you can see for Simpson's rule, there's a little gap in between. But for Temperature rule, you can see here there's a big gap here. Okay, now let's go on to the advantage and disadvantage. For Simpson's rule advantage, generally give a better approximation than Temperature rule. Simpson's rule disadvantage have 4 sums of even coordinates plus 2 sums of odd coordinates.